All right. Hey, everyone. Thank you for joining us today. We are super excited to host Jigyasa. And like we said, we've been waiting for this day for quite a while now to have Jigyasa with us. We are going to be conducting this as a fireside chat. So generally we have webinars or hands-on labs, but this, or, our roundtable, but this is the second fireside chat that we're having. Unfortunately, due to personal reasons, the first one I couldn't be part of. So this is my first fireside chat with AWAAI. So I'm excited for it. So if you guys do not have questions, then please keep yourselves on mute. And if you have questions for Jigyasa, then definitely unmute yourself and jump in. And with that, I'll hand it over to Uvika, who will introduce Jigyasa before we get into chatting.
Amazing. Thank you so much, Padmini. And as you heard from Padmini, that we have been waiting for quite some time, and I'm super excited to have this fire chat with Jigyasa and Padmini. And when I was looking at Jigyasa's bio, I was like, man, where all has she not worked at, right? So she is an award-winning leader and an author who has worked at some of the large-scale, companies on machine learning systems across companies such as Uber, Meta, Twitter, X, of course, Fair and Bordeaux AI. And at Uber, she currently focuses on rider personalization and large-scale innovation. So pretty cool stuff. She's also deeply involved in shaping the broader AI ecosystem and also serves on Google's developer advisory board. That is pretty cool. And she has also been recognized as the Google developer expert and contributing as a World Economic Forum Global Shaper as well. And many of you may also know her through her teaching. I don't know if you've seen, but she is also a LinkedIn learning instructor. And I have definitely looked at some of the snippets of her course, and it's amazing. She's helped thousands of professionals understand AI-powered applications and agentic AI systems with a strong focus on building production-grade and responsible machine learning systems. And her work and insights have been featured widely, including at Google I/O, Forbes, Business Insider, VentureBeat, and the list can go on and on and on. So with that, I'm just going to stop right here. And without further ado, we should dive right into the fireside chat so that you all also have an opportunity to ask questions and really pick her brain.
All right.
So we are going to kick it off. So Padmini and I are going to do the fireside chat. And as Padmini said, keep yourself on mute and dive right in, Padmini.
All right. Thank you, Uvika. And Jigyasa, I have to say this before we actually start. You had one video, I think, that you posted on LinkedIn where you had come into Google I/O the first year as as an attendee, and the second year you were right there on the screen. I love that it's a full circle moment, right?
Yeah,
So
thanks.
anyway, yeah. So so let's get started. And Jigyasa wanted to ask you, we are seeing this shift from, traditional chatbots like AI as your knowledge partner to autonomous AI agents, which have multi-step reasoning, tool use, and all of that. So from your perspective, what has fundamentally changed when we've moved from AI, chatbots to agentic systems, especially when it comes to reliability and evaluation?
Yeah, absolutely. I feel, I perceive chatbot as kind of like a function. You give it an input, you get an output. And it's mostly stateless, and I would say it's pretty much contained. Whereas agent can be thought of as a process and not a function because it would loop, it would decide, it would act on certain things, and then it would also react to the consequences of those actions it has taken over time. So, from that perspective, chatbots, the blast radius of any bad output that you might get is very much contained. Maybe a user sees a wrong answer, and the system won't really act on it. Whereas in an agent, there are like so many steps happening in a particular chain that a bad decision in maybe step two of like a 10-step chain would cascade. So you don't really get a good answer, or maybe like you don't really get like a wrong answer. You get like a completed workflow, which might be built on maybe a wrong assumption, or sometimes with like side effects that you cannot really outdo. So like when I think from like a more fundamental perspective, it's like the stochasticity compounds over time. So each tool call that you're doing, each sub decision ends up introducing some level of variance. You might think that an agent is like 90% accurate, but if you look at over from like a probability standpoint over like 10 different steps, like 0.9, you end up getting it accurate only, let's say, 35% of the time if you're doing like from like a oversimplification. So if each step were independent, which technically is not, the compounding intuition still holds. So you cannot just look at a single task accuracy and extrapolate, which you can do to chatbots to some of an extent. Also, agents maintain context over time. Like traditional chatbots were just like, they would just blurt out the answer if they knew that. So if you have, let's say, step 3, something happened, it actually affects and impacts what's happening in, let's say, turn 8. So evaluation isn't just you grading the final output. Like what I'm trying to say is like you have to look at the entire reasoning path. There are side effects because agents are not just giving you the answer back. They're acting, they're calling APIs, they're writing to databases, they're sending emails. So you cannot really just go back and undo some of the changes that it might have hallucinated. With AI and the agents that we're talking, it's mostly like having a to do plus a toolbox that you're giving. So you need to evaluate not only that it's working on the to do in like the right steps, but also how well it is using that toolbox and not just using the toolbox. So I feel like that's like a whole new discipline.
Right, and a quick follow-up question. When we look at chatbots and chain of thought, how do evaluations play in there? Because it's a chain of thought prompting, kind of a chain of thought reasoning. How is that also considered like a multi-step?
So when you're thinking about like chain of thought and multi-step agentic workflows, I feel like there are subtle differences in the sense like when you're talking about multi-step, I would assume like it's also interacting with other agents, whereas chain of thought would be more of an LLM quality, in my opinion. So you're asking LLM to think about it, whereas in a particular agent, it's calling these different tools in different steps and might even be interacting with other agents. So if we are just building agents using, let's say, out of the box LLMs, then most of it you would be focusing on the evaluation of the entire process. Like, what about the reasoning steps? Like, it actually thought over those. Did it select the right tools? Did it hallucinate between the immediate facts? And that is why multi-step actually helps with reduction of hallucinations because you're asking it to
Right.
divide that big task into smaller tasks.
Yeah. All right. No, thank you. Thank you.
Amazing.
Uvika.
So I actually wanted to unpack, something that you had mentioned that when you're working with LLMs, and of course, like with agents as well, right? That your answer won't be 100% accurate, right? You're probably going to get 90% there. And as everybody is running towards agentic AI, some of the things that we are seeing and people asking questions is that I don't know if I can trust the agents. Of course, there's one clan who will be like, let's go, I don't care, it's going to get the job done. So, and plus, we know that when we were used to talk about traditional software systems, they were more deterministic in nature. But agentic systems are more probabilistic, right? So, what, in your opinion, makes trusting AI agents harder than trusting traditional software systems?
Yeah, I think you kind of like built in the answer in that question itself. Like, because trust in traditional software is built on its determinism and the observability. If your code throws like a null pointer exception, it would immediately crash and tell you why it crashed because it observed like a null pointer exception. And the contract is like very explicit. Same input, same output, you will get an exception regardless. But AI agents, like in my opinion, they violate that contract of like input output and the crash reason at like every level. They are non-deterministic. And most of the time, if your wiring of, let's say, the LLM and the tool is correct, you're using MCP in the right way, it won't crash. It would just give you a plausible looking answer, which would be a wrong answer, in the most confident manner. So the crash in both the systems looks completely different. And because agents, the reasoning path is often opaque, you won't even know it, this is something that you should not be trusting. So the first step here would be to bring a level of transparency to that reasoning, maybe seeing what the agent did and why did it choose this particular tool over the others, and maybe over a dozen alternatives it had, and why were they discarded. I think that brings that level of interpretability at that agent level. Again, it is kind of like a research problem. I won't say it is something that has been solved, but bringing like tracing and logging at every step definitely helps. The other thing I was thinking was from like a goal perspective. Like if you are doing demo, if you're doing testing and you're just building the agents, you mostly do it in a very controlled environment. The agents behave well. But the moment you take them to production, they end up hitting the edge cases they've never seen. And that is where you cannot just extrapolate them into a territory they might not have any business operating in. And in my opinion, the more confined you keep them while giving them the most capability and ability is a key to having like trust in that domain. And the biggest thing that we are seeing these days is like the more fluent and the more structured the agent output is, the more we tend to trust it, which we might not even want to, and it might be even harder to spot the error. So maybe an agent that produces like a beautifully formatted wrong answer in the most confident manner is the most difficult to actually audit because you don't really know what went wrong. To give you a simple example, like this example kind of like stems from the chatbot. So we had that Air Canada chatbot where it hallucinated a bereavement refund policy that didn't even exist. It stated it so confidently, the customer relied on it. No one even knew like it made things up. So I think like if there would have been some sort of like transparency, like looking into the records or maybe like record not found, and it still gave you an answer, you might have to like double click on that and see like if it exists or not. So I think like that is where like traditional software, trust ends up being very binary. It either works or it doesn't work. In agents, like trust itself is projected into a probabilistic spectrum. It is very much contextual. It is very much time varying because this time you're not thinking about like, will this system work or not? You're thinking about under these particular conditions, with this frequency, does it fail in the ways I care about or not? So I think like that is a very different question and maybe even requires like a different way of evaluating that we've been doing so far.
Okay, so I have another follow-up question on that, right? Because you mentioned the Air Canada example, and when you have these perfect scenarios, do you have any suggestions on how to be able to basically find that needle in the haystack? That do you have any suggestions, for the audience? Like, how can they be extra prudent, especially when everything looks so perfect?
I think the biggest thing is like doing grounding and tracing, ensuring that at each and every step, basically, you have built in the observability, the tracing, logging, and from like a production standpoint, like that's what we've been doing is like have build a failure taxonomy before you even define what success means to you. Like maybe try to name the ways you feel your agent can fail in like certain contexts, and from day one inject trajectory logging with like trace IDs. You have so many tools available these days, be it like Langsmith, Arise, Phoenix, weights and biases, etc. And then these days models are also getting updated like so fast that it's very important to have this set of, let's say, high signal test cases that you run on every small, even like a minor version model update. And that is what helps you like catch regressions before maybe users would do. And then, of course, like building in grounding systems and displaying or even focusing on the reasoning that we talked about.
Brilliant. Thank you so much.
Yeah, I have one question, if it's okay. Yeah,
Yeah, go ahead,
you
Evan.
just throw it out. Okay. Jigyasa, how let's say someone creates multiple agents, how do you keep track of that? Is there some inventory or registry or something? Because you have so many developers and each is creating an agent, but then someone could be overlapping and say, we don't need this agent because we already have this agent. So is there a way to just track this through inventory or registry so that people don't get confused?
Yeah, sure. So I think like maybe before I answer that, I'll have a question back for you. Are you talking more from, let's say, maybe within an organization, in the open source space, or just agents available that you can call on, let's say, a per diem basis?
Yeah, more within an organization. So, we have 3 developers and they all want to use agents, and one person wants to use cursor, and then one person wants to do this, and it's like I know there's shadow AI and stuff like that, but I'm saying, let's say the organization allows us to use cursor or something, and then we just create agents. I still want to know how to track that. I want like a registry. I want like a marketplace that say, oh, go here. We already have that. Like, how do I even know what my workers are doing if I have 10,000 workers? I mean, it just seems so discoordinated, you know?
Yeah, so I think like when you talked about, let's say, Cursor or Claude, Coder, etc., I would count them as AI tools. But yes, those AI tools and can be used to build agents. And you within an organization, like that's what having like a centralized place where you have like an agent registry basically. So a lot of internal cataloging tools are available which are like similar to how you would do like a backend registry, where maybe every agent is registered with its metadata, like what is the purpose of it, what kind of like tools it would require, what kind of like data sources it has access to, the ownership, etc. So yes, and that is like a very good way to go about. Let's say multiple teams are building different things and they can still have their own agents interact with agents of the other teams. There are I think like certain tools that will help you like build those catalogs, like you, let's say you use langchain and llama index or whatever to build the agents. You can build registries within that as well. And if you're looking for something, let's say you are a Google Cloud provider customer, then they have their own agent space where not only they publish their own agents, but you can publish your own and then use it within your own organization as well.
Oh, okay. Okay, thank you.
Yeah.
And I think Evan, just to sort of add a little bit to that, MIT has this project called Project Nanda, Nanda, and that is basically an internet of agents. So you go there and you register an agent that, so this is not within an organization. This is, across the globe. So you go in there and you register your agent, and they have like these internet of connected agents. So if you are a person sitting here and you want to consult somebody 2 states away, your patient, like a doctor and you're a patient, your patient agent can go to Project Nanda, look for a doctor agent, and then that doctor's agent and your agent can talk to each other. And so basically it's one step beyond like your first MCP, then A2A, and then Project Nanda kind of. It definitely take a look at it. It's very interesting.
Yeah. And if I wanted to trace all that, is it that's what I would figure out. How would I trace like who talked to what, I'm just always thinking, how do we log this? And if I'm sitting inside a company and doing that. I'm always thinking, how do I log everything I do? And I'm just, that's thinking too hard. I'm thinking too deep, and I'm ruining everyone's fun. But
No,
that's
no,
how.
no. But check it out. They have
Yeah.
I will.
logging. They have
I
all of
will.
that.
Yeah, but even Microsoft, now with their M365, they
Yeah.
also, you basically every agent that, your company or whatever ecosystem like it's using, an agent has an ID. And if you even have a Slack also has agents. So you can actually see all those agents and the
Exactly.
interactions that are happening with the
Oh.
other agents. So
Oh, great.
Microsoft
Yeah,
has
yeah.
that tool, but I think other people are also trying to catch up with that. But anyways, bringing
Yeah.
stuff back to you, Padmini.
So, Jigyasa, we talked about agent giving like a wrong answer, flawed answer at the end of it. But what happens if, the agent finally gives us the right output, but through like a flawed reasoning? So
Mhm.
the final answer is correct, but the steps to come to that is incorrect, and one may wonder, how is that even possible? But there may be cases where, you have a flawed reasoning, but you eventually get to the right answer. How do we think about evals, or how should teams think about evals in such cases, where, compared to your traditional chatbots again?
Yeah, I was just thinking you mentioned about the doctor agent, right? I was thinking like there can be doctors who maybe arrive at the right diagnosis,
I
but
know,
maybe for
right?
wrong reasons, right? So
Yeah.
technically a correct problem, but practically a very dangerous pattern. I think.
Exactly.
Yeah, so benchmarks are definitely great. Like, they will give you, like, so what happens? Like, you have this SWE benchmark, gold standard for coding agents, let's say, and you'll have like frontier models like scoring 80% on it. And the moment you bring, let's say, any pro version, which, let's say, there's like a pro version, I feel like, of the SWE bench, and it is more like enterprise realistic variant, the benchmark results will like drop. And I think like similarly, let's say if you were to try a coding agent, which was like traditionally meant for coding only, on something like Web Arena, which is meant to test agents on like more realistic browser tasks like booking flights and managing calendars, etc., or maybe like doing some file management, you'd see a lot of like things that'll break, because what I feel like is some tasks are meant to be more constrained, let's say the coding one, and some like Web Arena, because browser based tool use can involve like ambiguous intermediate states that sometimes code might not. So the point that I'm trying to make is sometimes single task endpoint accuracy doesn't capture the failure modes of an agent. And that is what like we were talking about, like agents can reach correct outcome through hallucinated reasoning or inefficient,
Yeah, exactly.
or maybe even lucky recoveries, like they might have just been lucky. So if you're building evals for those kind of like agents, the first thing that you should do is like not focus on the final outcome. Like outcome evaluation is great, but focus on the trajectory, like how it actually came up. And that is where, to Evan's point, like you need to log everything. So for example, like Microsoft's AutoGen, which helps you build agents, has this
Right.
built-in conversation logging, which like a lot of like teams would use to inspect like message chains and see like, did the agent use the right tool in the right order? If it like failed, was it able to like auto recover from that immediate failure? Why would it take like 10 steps to reach here when in an ideal case it would have taken, let's say, less than 3, because it's not like too hard of a problem. So that is where you need to build those golden data sets to do evals. And because if it took an like 8 to 10 step path, maybe it just like went off the tracks,
Yeah.
and and ended up coming back. So maybe you don't want that in real life, because not only it's not following the traditional path, b, it is wasting you maybe a lot of like LLM calls and latency and cost to end up in the longer run. So along with the tracing thing, I feel like one thing that we've been trying to do is also like a lot of like behavioral consistency testing. So have the same task run over and over with like some small perturbations in, let's say, the prompt. because if you observe a very high variance in the reasoning chains for that particular task, it does indicate there is some sort of like brittleness, and not the capability is not something that's being triggered. So the idea is real reliability would mean there's low variance in that and not just like high average performance in the long run.
Right. And as part of these evals, like these intermediate evals, are these typically, like, I know manual evals are not scalable. Are they more of like LLM as a judge, automated evals, or what do you suggest as?
That is also a very, very interesting problem for the agents and LLM space itself, because they are so much open-ended and they're multi-step, and the environment itself keeps changing. In my opinion, there is no one method that you can follow for doing the evals. You have to have like a combination. So let's say the first would be human in the loop. Now humans would like review, let's say, samples of certain agent trajectories, not just final outputs, and that is what you're asking humans to grade. You start with final output grading, and once you figure out that the final output was correct, you go to the whole trajectory. It is being used by a lot of like big companies, like Anthropic has outsourced it, OpenAI has outsourced it, etc. And there are literally training programs where you train reviewers to review the agents, where they can spot like where it went off the rails and so on. But this is very high signal and high effort annotation task, as you yourself
Right.
said. It is not something scalable. So I would use it, but limit it to something that is for very high stakes deployment, because there is no substitute for this ground truth calibration ultimately. But then there are cases where we were talking about, the prompt perturbations, like LLM as a judge would like work great in those scenarios. So I know, I'm pretty sure like a lot of people might have seen the LMSys chatbot arena. It's basically an extension of LLM as a judge into a live crowdsourced ranking system mixed with human in the loop. So they use both these methods, and that is a foundation I feel like a lot of smaller organizations might be working on, or even bigger one, is like, because LLM as a judge scales, it is powerful, and you can do it over like say thousands of trajectories all at once. But there are downsides of it as well. So there's a very interesting research article that I was reading, is where um, LLMs prefer responses which were written by LLMs, and that study was practically done on GPT-4. So GPT-4 would systematically prefer a response which was written in the GPT-4 style. Apparently, LLMs can tell which response came from which model. So maybe that, if you tell the judge that it got wrong, it will often also agree with you, and because it's came from the same family of models. It's a very interesting article, in my opinion. Um, there's also another thing that came for LLM as a judge is, let's say if you give it three answers, it is always preferring the first one that appears first, or sometimes it would also appear the one that seems to be longer and nicely formatted. So I think like those are some things that maybe you should keep in mind. And now people are moving away from like using a single LM as a judge to using like a panel of judges, and doing this voting methodology. So the idea is, who is evaluating the judge, who is evaluating the evaluator.
Right.
What if the judge itself has bias, etc. So you move away from choosing the best technique to like choosing who will be the judge. So I would say, to sum up all of this conversation, is like, do not rely on like one single method. Have some heuristics in place. Have human in the loop for ground truth calibration. Have LLM as a judge for like coverage, and then some deterministic metrics for like regression testing, etc.
That's very helpful, because I was also thinking like maybe you fine tune one of the LLMs to be the judge. So you fine tune it so that it has the right training to play the role of that judge. But no, this is very helpful. Thank you. Yuvika, over to you.
I'm going to ask you about my favorite topic, and I think a lot of you know about risk and governance. So, would love to understand from your perspective, when we are talking about risk and governance, what are some considerations in those domains that would be very important as agents become more and more autonomous?
Yeah, I feel like the idea is who is at fault when things go wrong. Is it the model provider, or is it the app developer? Um, is it the operator or the user? So sorry, I got lost in my train of thought. Could you
That's
repeat
okay.
that?
No, but I think you
I
basically
kept
point
thinking,
towards that, who's ultimately
yeah,
accountable, right? So the accountability probably needs to be defined, in your
yeah.
opinion, right?
It's basically, I feel like it's not like a one-off bug. In my opinion, it's like a systemic problem that maybe like no one would feel like they are the cause of, they are responsible for that. So governance in here would be taking accountability, and the core issue would be like accountability still ends up being very much diffused. So having that scaffolding of like teams in regulated industries need to be building towards, and not wait for like the final specs to come out to ensure there is governance in that agentic space.
Okay, but just to kind of so just to kind of maybe talk a little bit about in terms of practical steps, right, that people can take on how to improve as they evaluate AI agents. And I know you said that it cannot be like a one size fits all approach. You have to try multiple things, right? But for people who are just kind of getting started, what would be your recommendation to them, so that they know that, okay, of course, we keep hearing that it's human in the loop evaluation, and there is LLM as a judge, and there are others. But what would be some, at least like one or two, that they can say that, okay, and keep improving on it?
Yeah, I think we kind of like touched that in the beginning as well, is to first of all figure out what your failure taxonomy would be, along with the success metrics. Maybe what context do you like feel your agents might fail, and along with that, have that escalation criteria kind of like very explicit. Like maybe the problem arises when the like you don't know what the agent doesn't know. So I think like that is like prompting the agent, ensuring that it should be very much capable of like understanding its own limitations, when the agent should stop, maybe stop hallucinating or trying to come up with the answer. So I was just like listening to a podcast by Anthropic. It's like a video on YouTube. Basically, it's about reward hacking. So what happens is like if you ask Claude Code, let's say, to write unit tests and make them pass, like make the code pass, because it is so keen on making the end users satisfied, it would write unit tests where ultimately the test would be in such a way that it would be like return true, return pass or something like that. And you don't even know what's happening under the hood. And if you are, as an engineer, using those AI tools and thinking that uh, you have like this full blown test suite, you have 100% test coverage, but what's happening under the hood, you don't know. So reward hacking, and that is where you should be ensuring that your agents knows its limitation. It should know when to stop, when to escalate to human, or just outright refuse. And then afterward like treat violations as kind of like very much of like a big production incidents.
I think that's very key, right? Because you actually touched on a very important point, and a lot of people actually miss on that, right? You need to define the boundaries. You basically need to tell that this is where you should be stopping, this is what you should not be doing, and what you should be doing. And I think to your point, what you mentioned, that because they're so keen on pleasing us, I believe that last year we had read something similar. That the way the agent responds to you, it's actually, it knows that even when you're trying to break it, like these LLMs and stuff, they know that you're trying to break them, right? So they'll basically it's almost like you're watching somebody and they know that they're being watched, right? So
Yeah.
and when it does that, it gives you answers just to kind of make sure it's tricking you. That's scary. So,
Yeah.
but no, those were actually some great pointers. So thank you.
Yeah,
And
absolutely. One thing that I also wanted to bring up is, prompt injection, I would feel, is the new SQL injection. People are writing like prompts in such a way where they are asking the agents to reveal its system instructions or like to fetch. So having that role-based access, just like how you would do for any employee of the company. And using tools like Prompt Foo, for example, to ensure that your red
That got
team.
acquired. You heard that, right?
yeah,
That's
yeah.
so basically anything, and not just looking at the base prompts that would like, where the entry point of your agent is, but assuming that adversarial inputs can enter anywhere in that chain. So each part of that chain should be like well tested.
No. In fact, I think this whole thing about LLMs trying to please what we call the sycophancy bias,
Yeah.
I believe 5.4, the latest version of GPT has reduced that. And I really want to, yeah, and I can't wait because it's almost disgusting to keep hearing, that is a great insight,
Yeah.
it's like I'm done with it. So, um, but so basically, if for when organizations are going from like demos to production, we have what is called observability. So number one, if you can just for our audience, just explain what observability is, and as part of that, what would you say would be like if somebody has to like the top three or the top five things that we have to watch out for in production, that we have to track, what would you say those are? And if you can just start off with, just defining observability for whoever catches this even on the rerun.
Sure. So from like a very, like I'd say simple point of
Mm-hmm.
view, I would call observability where you can observe the behavior from like far away, and that includes behavior like at each and every step. Maybe it's the log, like every tool call, every intermediate output,
Mm-hmm.
every reasoning step, maybe with timestamps, with the token counts, with latency, with a trace ID that kind of like basically would tie the whole chain together. I would call it something as like a full trajectory logging in the context of like agents. And there are a lot of like tools that are helping you with like agent tracing. For example, if you're just using like open source LangChain, you have Langsmith,
Mm-hmm.
which is like widely adopted in this whole
Right.
Lang family. There's this Arise Phoenix is another open source alternative. You have like weights and biases, and of course if you're using any of the cloud providers like AWS or GCP, they kind of like provide you with those as well. So the whole idea is, in my opinion, like observability adoption is kind of like ahead of evaluation adoption, because again, teams have rushed to productionize and they know they need visibility, and they're kind of like now figuring out, okay, what looks good. So yes, we are kind of like ahead in evaluation, like observability evaluations kind of like still catching up. And to answer the other part of the question, like what you should be doing is,
Mm-hmm.
as I mentioned, like it should be not at end to end. Let's say if you're logging latency. Now it should not be something like that is being tracked end to end, but at like each step level, like breakdown. So because aggregate latency would like hide a lot of like pathological cases. Maybe an agent that occasionally enters on some sort of like retry loop for one tool call might look great in P50 metrics, but like terrible in P99. So
Mm-hmm.
the Langsmith has this waterfall kind of like view where you can actually see each and every step latency. So it like helps you visualize better. Um, so that was from like a latency. And when we're talking about tool call, I think there should also be like focus on like observing tool calls, like maybe which tool call gets failed most often, which gets called in unexpected sequences, having some sort of like anomaly detection
Mm-hmm.
mechanism on the process of like calling the tool themselves. So Arise has this anomaly detection module where you can look at the tool calling sequences that are happening and run that anomaly detection on top of it. So basically, any sort of like unusual sequence that you will see of the tool call is a signal of like agent not behaving as you would like to. So before it even manifests into the final output, as we were talking, sometimes the way it is calling certain tools would let you know certain things are not working. And then another thing that also comes up as a part of like observability, I would say, is the model version. So anytime, even like 5.4.1, for example, or 3.0, like even like a subtle shift from, let's say, Gemini 3 to Gemini 3.1 can, shift the agent behavior in subtle ways, which you might not even recall. So there's a term that we call it, it's called like agent decay, is slightly and steadily it will like decay the performance and you would not even realize. So it's very important that, whenever you're trying to log all of these, you should tag every trajectory with the exact precise model version and not just like Gemini 3 or like GPT-5, because just like how we did in traditional software, right? We had every major version and minor version, and we treated them as code deploys. I think like we should be doing the same with agents and the model updates as well.
And then when these model drifts also happen, similar to agent decay, when there's a model drift, that also impacts the whole behavior of the agent itself, right? So that then becomes another thing to keep an eye out for.
Yeah, absolutely. Like even calling of the tools, sometimes shifts, even if you move from, let's say, Gemini 3 to 3.1, because maybe they have better reasoning and maybe better understanding of like what tool to call or not. And one thing that I was like just reading over the weekend is how the descriptions in the tools that you provide, let's say via an MCP, because no one is, putting a lot of focus on that, but the agent does. For agent, that is kind of like the only source of truth. And there have been cases where tool descriptions have been contaminated to such an extent that they end up being the points of attack.
Oh, interesting.
Because for agent, like they know nothing else. For them, that is the source truth. And if the tool description asks them to like reveal all the system instructions or like reveal like go fetch that particular data, it will, because that is what it knows. So I think like they're definitely with agents and AI and MCP and A2A, we have exposed a lot more surfaces for attack.
Interesting.
Right. If I can ask a question real quick about, because we tried to use Arise, and the one thing we found, it's got a learning curve. And we didn't want to use Phoenix, the open source. We wanted to use the full version. And some people were saying, well, which machines do we attach to it? Because you have to instrument everything, you have to connect to it, and it takes some setup. There's a learning curve, but once it's set up, it's very good. But how do you avoid fatigue? Like, how do you avoid looking? Because if someone is asking me, my manager is saying, let's track everything: tool accuracy, reliability, task success. Give me the 3 top things so that I don't have eval fatigue. What do I do?
Yeah, that's that's a very interesting and I would say like very, very real problem. How I personally approach this is being very incremental in my approach. Not trying to like do everything at once, because yes, it can bring to a level of fatigue. The other point that you brought up is like how to track this and track like multiple things. I would say like we are in this era of like AI tools, and a lot of these tooling will help you like once you've connected all your data sources and the way your like I think setup is, as you said, like learning curve. Setup is the hardest part, and once you've done that, like these tools basically help you like track mostly anything and everything as of now. So I'm not really sure like if that really helps your point. Like when you talk about fatigue, what kind of like fatigue are the parameters? Yeah, if you could like, I'm not sure if I'm getting your question exactly.
Yeah, like we have to. They said we have to instrument everything, and we have to. I want to trace a machine. I want to trace an endpoint. We have to instrument it. We have to add some setup to it and connect to it.
Mhm.
And the developer was saying, oh, this is a lot of work.
Yeah.
Because he said he doesn't want to instrument every machine. So if you leave out a machine, how do I know that's not a machine that we need? That's not a workflow that we need. So,
Oh,
I
got
think,
it.
yeah. And if someone, do they hire outside people to come help set up these tools? Because for large company like we used to use Prometheus, that's open source, but even that's hard because who can figure all this out, and then set up the dashboard. It's like, do they have just people specialize in doing this to come in and just do that?
Honestly, I feel like yes, there would be folks like if you do like from like a partnership perspective, but the in practice, like there's like an incremental way that I was saying, like you should maybe focus on high impact metrics first,
Hmm.
instrument like the whole agent framework, so that like every like focus on the agent runtime and then you can send those traces. This whole setup, as you yourself mentioned, is a curve, and you would need to have like these standard schemas assigned and defined, so that the agents are reporting in like a consistent way. So maybe start with like agent ID, step type, tool used, reasoning step, etc. The tool itself, like Arise Phoenix, yes, it is hard. There can be folks that can that can come and set it up for you, but instead of like evaluating every detail, start incrementally. Start with like trajectory consistency, tool usage, correctness, hallucination rate, and then kind of like build on top of that. And one tip that I'd like to give you is like try to automate as much as possible. And like automation is something that's like the keyword for 2025, 2026, right? So set up visualizations, set up automations, and that'll kind of like help you focus on like where to dive deeper in the future. But tool use, yes, tools exist. To learn how to use that particular tool is something that we have to put in time and effort.
Right. That helps. Thank you.
Amazing. Anusha, you had a question. Did you want to ask Jigyasa?
Yeah, yeah, right. So I'm just curious to know about the adaptability rate of the AI agent in the enterprises, because or like which industries like do they implement AI systems, and I'm just curious because I see many enterprises are still stuck in the digital transformation, like not in terms of procuring the system, but in utilizing it effectively. So, which kind of industries are actually like implementing the AI systems, and what do you think would be the adaptive? I mean, what's the current adaptability rate?
Um, when you talk about the current, like one thing that I've observed being, like in San Francisco Bay Area is consumer apps see the first glimpse of anything new that comes up, because in my opinion that is a area where there is most excitement, there is most growth. But then there are industries, let's say with healthcare or finance, where any small mistake can have like a huge impact. That kind of is the whole spectrum, where you would see basically the adoption uh, diverge. So there are early leaders. You have a lot of like tech and digital workflows. They, in my opinion, there are like the fastest adopters because they're not just experimenting with agents, they're actually putting them to use. And then there comes this finance, healthcare, retail space. In my opinion, they mostly look for ROI. And for example, retail and e-commerce might be looking for agents for personalization and like return and refund workflows, inventory automation, etc. But then you have this public sector or professional services, or let's say telecom and logistics. Since they don't come from this typical tech background and their foundation might not be as strong as we've seen with others, I think like that is where you would see some sort of like mid-level adoption. They are trying to pivot there to using agentic systems for, let's say, like supply chain monitoring, etc. but it comes with a lot of friction because of the talent, and a lot of like ROI constraints and seeing measurable efficiency gains, for example. So a lot of these professional and technical services, they are integrating agents, let's say, into analytics and project management, but on the ground, like physical AI is somewhat limited. And same goes for industries like, I'd say, manufacturing and construction and traditional sectors. Overall, I feel like that is the landscape. You'll have everyone from across the spectrum. It again focuses more on the level of ROI that you're looking for. Is it more short term? Is it more long term? How much of integrating that agent can actually lead to impact on your end users? Because adoption tends to be more high in customer facing and digital operations. And ultimately, it's also a point of like governance, as we talked about, like healthcare and finance sectors specifically.
Thank you. Thank you for answering.
Yeah.
And we have like few more minutes left.
Yeah,
Anybody
so I think we'll
else
try
with
to maybe,
questions? Yeah.
we'll try to close it out, right? If you don't have
I think
anything.
Sai probably had a question.
Sai, go
Yeah.
ahead.
Yeah, I was just waiting. So all these are kind of a bit eye openers for me, but I think I mean I'm getting some context and logic out of all these things. Really very helpful, Jigyasa. I mean on this. Maybe this is a basic question. I don't know. Just I'll try to put this across. So you had talked about failure taxonomy, which really felt very good process of, placing a tech evolve system. And we all know human evolve is kind of golden standard compared to tech evolve. So, but human evolve system cannot scale cost. We have to incur a lot of cost. So is there any set, or a standardized framework or proven framework um, where we get the results of failure taxonomy that can be automated and automated as a human and or make it automated as a tech evolve system, which is very close to human evolve system.
LLM as
Does
a
it?
judge.
Yeah. Yes. Yeah. So is
I
it
think like
possible? Because in terms, see, we cannot bring so many human evolve. So based on like if we would have standardized the framework and we train again one LLM, based on that, do you think that will work?
I feel like, yeah, LLM as a judge is like coming in between exactly what you need for human evaluation. And
Yeah.
we talked about like automations. Yes, it can be automated, but there are failure points that we were discussing previously as well. Like so instead of like having a single judge, maybe have like a panel of judges.
Okay.
And the best way to implement that would be have like a scorecard, like a proper scorecard on the different parameters that you want, let's say, the result to be evaluated on. And that kind of like brings in some level of determinism. Give it like some examples using few short learning. What kind of like evaluation are you expecting? A scorecard on different parameters. I think there is, yes, you can definitely, to answer a question, yes, that is definitely something that can be automated. And that is a lot of automations that are being done specifically as you move from, let's say, smaller model variations, right? We were talking about, let's say you move from Gemini 3 to 3.1. Now you cannot have a human evaluator evaluate every single instance because you haven't changed anything in the agent code drastically. You just have changed the model, and that too by a minor version. So that is where evaluation systems like these come in really handy.
Yeah, that makes an answer, but I'm just worried if we create an LLM as a judge, maybe we have to create another failure taxonomy for it too.
Absolutely.
So
It's
it
an
goes like
infinite
a
loop.
loop. I'm just thinking through that. Yeah. Okay.
No, I think that's a really good point. And we were also touched upon like who is judging the judge themselves. So that
Yeah.
is,
Yes.
Yeah.
Amazing.
I guess
All right. We're almost on time. So does anybody have any other questions before we wrap it up? No? So just to kind of summarize things, Jigyasa, we don't want this to stop. You have a wealth of knowledge, but if you had to put everything in context, and you had some amazing things that you touched on, looking out a few years from now, how do you see the evaluation space and governance of AI agents evolving? And what can people do to prepare? But not now, but what can people do to prepare for the next few years?
Yeah, I think like that's a very interesting point. I was like one of my friends works in venture capital, and one thing that they were discussing is like one of the biggest unsolved bottlenecks in today's space is not only enterprise AI deployment, but how to evaluate that AI deployment and to figure out the correctness of it all. And from like a arc perspective, I'd say near term, I see a lot of like benchmark diversification. We've already talked about like SWE-bench and Web Arena, but moving away from single task accuracy towards more multi-dimensional behavioral assessment. Because we've seen like this ends up getting messy because the task space is like so much broader and very, very hard to standardize. So this is one space I feel like a lot more effort would be put into. Uh, and along with the fact, of course, like having audit trails, and if your, let's say, agent made like any consequential decision, um, a lot of these financial services and healthcare, they are trying to produce a human readable explanation of that reasoning chain. So there are temporal, for example, they help you with agent execution. And I feel like they're kind of like moving into that same space is to avoid any sort of like compliance debt, because previously we used to have a lot of like technical debt, but now we are moving towards where we might have like compliance debt. And similarly, a lot of like these data protection regulations and AI laws need to get updated as well. Like it's not just about deploying agents and ensuring that they're compliant to like data rules and policies, but it's more about how you're bringing in human values and ethos into that. So I feel like that is what I see in the mid to near longer term as well.
Amazing, super. I could see a lot of nodding heads because there are quite a few people from compliance and governance and in that arena. So I could see their eyes lit up. But I think that's it. We're 3 minutes over. So Padmini, I'll hand it over to you to close it out.
Yeah, no, thank you so much, Jigyasa, for this wealth of information. I think you kept us all engaged, and thank you for sharing all your knowledge. And thank you to each and every one of you to spend your Wednesday evening, Thursday early morning with us.
Yeah.
So appreciate it, and have a good night, everyone, and good morning to Anusha and
Thank you.
Salim.
This was
Thank
great.
you once
Thank you
again,
very much.
Jigyasa. This was amazing. We
Pleasure.
didn't want you to stop. There's a lot of stuff we learned. So
Yeah.
thank you, everyone.
Thank you so
Bye.
much. Have a
Thank you.
great one.
Okay.
Thank you.
Appreciate
Have
it.
a good
Bye-bye.
evening. Bye.